Hello and welcome to the InfoQ podcast. I'm Daniel Bryant, News Manager at InfoQ and Product Architect at DataWare. And I recently had the pleasure of sitting down with Zhamak Dehghani, who works at ThoughtWorks as a Principal Consultant, member of the Technical Advisory Board and Portfolio Director. I followed Zhamak's work on microservices, data engineering and leadership for a number of years now, and we most recently bumped into each other at QCon San Francisco, where she was talking about data meshes. I thought this was an intriguing topic and I was keen to know more. My first questions revolved around the motivations for becoming a data-driven organization and understanding the challenges of adapting legacy data platforms and ETL jobs. I was also keen to explore the concept of several architecture failure modes within existing data platforms that Zhamak had talked about at QCon. And finally, as I also currently work on platform building myself, I was keen to understand how to design and build the next generation of data platforms, using ideas from things like domain-driven design, product thinking, and also applying principles such as self-service and making it easy to do the right thing. Hello, Zhamak, and welcome to the InfoQ podcast.
Hi, Daniel. Thank you for having me.
Could you introduce yourself and give some brief recent career highlights, please?
Sure. My name is Zhamak Dehghani, and I work for ThoughtWorks as a principal consultant. I wear various hats. I act as the technical portfolio director. What it means is that I work across multiple clients, portfolio of clients, and I play the role of the technology director, helping the teams on the ground with technology decisions. I also sit on the tech advisory board for ThoughtWorks, which produces the technology radar. Again, it's a great vantage point to have to see projects that are happening across the globe by ThoughtWorks on the ground and be able to digest the information we learn and publish that to the industry.
Excellent. So you and I have kind of crossed paths for many years now, talking about microservices. We were just talking off mic about Sam Newman arranging a program at a conference you and I both spoke at. Today, I'm most interested to pick your brains around the concept of data mesh, which I've seen you talk about recently in a fantastic blog on Martin Fowler's site, which I'll make sure to link in the show notes. Before we dive into the concept of data mesh, I'd like to explore the problem space a little bit. So when we say a lot of organizations want to become data-driven organizations, what is the reason for this? What's the benefits of becoming data-driven?
Yeah, absolutely. It's a good place to start. And that's how actually the idea of data mesh came to exist, by looking at the problem space, what we're trying to achieve, and the challenges that we have. So working with a lot of clients mainly in the West Coast of, US, where I'm located right now, I noticed that, a lot of CEOs, CIOs, CTOs have this mandate of becoming data-driven. Treat data as assets. These are the kind of the phrases that you commonly hear across the organizations. What it means is really to use and harvest data to either improve the operational performance of an organization. For example, you may have a lot of manual decision makings or manual interventions with your customers, and you want to improve the operation of your organization. If you're a commerce company, let's say you have a online commerce function, and you want to price the products that you're selling, and you want to price them more efficiently. Price optimization, for example, is a function of online commerce using data. The other aspect is really treating the customers better, providing a better customer experience, using the data, the knowledge about the customer behavior and the customer history, so you can serve them better. You can sell them, again, in the commerce, using commerce as a domain, because it's just such a well understood domain for the audience. Again, to serve your customers better, you use their data to personalize what you offer them, what you suggest to them to buy next. Again, it's either around optimizing business, essentially removing operational cost, or serving your customers better. And at the end of the day, competing with your competitors using the data and information and insights that you have about your business, about your industry, about your customers.
Excellent. So I'm definitely hearing a lot of things about, say, experimentation, because companies want to experiment and see what their customers actually want, and they want to do it faster than their competitors.
Absolutely. I think experimentation is a big element of that, because, rule-based decision makings are easy. You make rules and logic and code it, and then you kind of put it out there. But when you're speaking about changing your business based on data, a lot of it is based on experimenting and gathering insights, tweaking your business and see how the customer responds. And again, harvesting the data, which is the response of your customer, and back into the system. We have a nice name for it. We call it the cycle of intelligence, or connected intelligence, which is about connecting the actions and interactions with your customers, the data that is produced from the interactions and actions turning that data into insights and then turning those insights into augmented intelligent decision making. So AI based or ML based decision making, and augmenting those actions and interactions. And you can see that it's a cycle. If I had a whiteboard, I would draw a cycle with actions and interactions and data and insights and again, intelligent decision making.
Excellent. So what solutions as an industry have we explored in this space before? Because I've done a whole bunch of work back in the day with Java and data warehouses, these kind of things.
Yeah, it's an interesting kind of evolution. I think there is a spectrum of tooling and technology out there. Maybe for this conversation, we focus on kind of analytical data management side of it. If you think about that cycle that we talked about, at the top sits the applications that we build, right? The computes and, platforms that run our applications and we build our applications. Then as you come through this cycle, then we talk about the data itself. How do we manage, capture, and, serving this big analytical data that then we can on top of it build machine learning and AI models that augment those applications intelligently. So maybe for this conversation, we just focus on the data management side of it and see the trend of technology and maybe to some of the challenges that those technologies have. At a very high level, I see 3 generations. Maybe there are many generations in between. But early days of big data or 40, 30 plus years, analytical usages of the data have been, I guess, contained to what we call today analytics, which is around reports, visualization of your metrics. What are your KPIs? So how is your sales trending? How's your customer, segmentation trending? So it's trends analysis and basically analytics. And the technology that addressed that concern and that particular use case of the data where, as you mentioned, there were data warehouses where you are basically gathering through these ETL jobs and, extract and transform and load data from various operational systems into one giant warehouse where data gets very, carefully modeled into these schemas against which you can run essentially SQL queries in all sorts of forms and make all sorts of queries and visualize and see the data. And at the end of the day, behind those data warehouses, a human would sit and look at that report or look at that visualization. And that has been okay for that particular use case, for those reports, right? Those monthly reports that you throw a whole lot of data people at this proprietary piece of technology, the data warehouse, to kind of model the data carefully and come up with thousands of reports and thousands of tables and so on. And that technology was okay, but problematic at scale, particularly not relevant to kind of the data scientist type access, right? AI and ML based type access where you don't want a pretty, carefully modeled data. What you want is those facts of the business as they happened in a more raw format. So we kind of evolved from data warehouse to data lake. And the data lake was pretty much the same in some ways in data warehouse, that it is still assumed that the data would get extracted from the point of origin where it's originated. And now instead of carefully being modeled, it's just get dumped in some sort of a raw object, storage or file-based storage or columnar-based storage. You just get dumped, and then you can kind of unleash these data scientists and to swim in this lake and figure out, what insights they discover. And I yet have to see a lot of successful cases where we gather insights from this data. And then downstream, once we figure out what is it that we want to extract from this data, those downstream APIs and model data marts and so on come to play. And that is dominantly the paradigm we live in right now. In terms of technology, we've gone one step further, and now we talk about lake on the cloud. And we talk about pretty much the same paradigm of warehouse or a lake, but put it on the cloud. And then that comes with its own, tech stack, which is different from the tech stack we would be running on-prem.
Very nice sort of an overview there. So I was reading on your recent article I mentioned already on Martin Fowler's site, and you talked about architectural failures of existing solutions, which I thought was an interesting concept that applies not only to data, but just, I think, software development in general. But zooming down to the data space, could you explain a bit more about these failures? And the first architectural failure was being centralized and monolithic.
I guess I saw these failures. I was shocked, to be honest, because I came actually left field to the data from the distributed computing world, from a world where decentralization of capabilities and decentralization of ownership of capabilities was kind of a norm, or it was a North Star, for people to get to. I mean, you and I crossed paths talking about microservices. So seeing that and then coming to the world of big data, I was rather shocked that even the most modern articulations of the big data architecture involved a centralized lake. I mean, you talk to CIOs and they say, we dream about putting our data on the lake. And, all of the incentives are aligned around getting this data into the lake on the cloud. And to me, it was kind of shocking because I came from a different world. And I think that has been, to be honest, some of the symptoms of this centralization, the failure mode of centralization that I see are around any centralized architecture is really hard to bootstrap and is really hard to scale and is really hard to get value from. So talking about centralization, if you look at the warehouse or the lake on the cloud, just go on any of the cloud providers and look at their data lake architecture. What you would see is basically the articulation of the architecture is wiring a bunch of technology that at the end of the day moves data from ubiquitous systems or hundreds of operational systems into one place. And we all know about, Conway's law. We structure our architecture, which reflects, the communication and then the structure of our teams. So one lake to rule them all, or one warehouse. And then downstream, you are expected to have all these proliferation of consumers connected to this one lake and get satisfied with one lake. All of the big data architectures that I see today have a very much monolithic and centralized view of the world. And most importantly, that view is dictated by the technology. I mean, the most fundamental concept of any universe we live in, any company, any organization is the domains, right? Is the function of the business and the data that this business either generating or consuming. And that domain thinking and the decomposition around domain is completely lost when we think about big data, because it's all about decomposition around technology. I mean, any monolithic architecture at some point will fall under its own weight. And then the architects, the question that keep them up at night is how I'm going to break this up so I can scale out my operation, right? And the architects in the big data domain or organizational folks and folks who think about organizational division of the labor in the big data world have come up with the idea of the pipeline at best. Dividing the work around pipelines and the phases of the pipeline, such as ingestion phase and, transformation phase and serving phase with data marts and so on. So the architecture not only is monolithic, it's void of the domain, which to me is the most fundamental concept in any business universe. And then it's the division of that monolithic around technology than anything else.
Excellent. So I'm keen definitely to explore that a bit more in a minute. But one of the other failures was, and you touched on it briefly there, was coupled pipeline decomposition. Could you break that down a bit more, please, Zhamak?
Sure. If you talk to any data engineer or listen to any data podcast, the phrase that you hear most about is data pipeline. And I have a dream. I dream to really remove the data pipeline out of our vocabulary. And there is a reason for that. So data pipeline is, as it stands with a lot of data architectures today, is your unit of architecture. So how you break down your architecture, most likely organically, not systematically, is around pipelines. What a data pipeline essentially does is a set of jobs that are responsible for consumption of the data from some or multiple, one or multiple upstream sources of the data, and then run that data through a bunch of, transformational jobs to transform that data to the format that is, applicable to whatever that consumer pipeline job is. And then a big purpose of the pipeline is really to consume data from upstream sources, then cleanse it, because usually the upstream sources don't take the responsibility of providing trustworthy, meaningful, correct data. So that cleansing becomes the burden of the downstream consumers. So cleanse that and then transform it into the format that is usable for the consumption of that pipeline. and provide that data for downstream. So provide that data either depending on the consumer access model or depending on the pipeline job, provided either as columnar files, Parquet files on some sort of object storage or data lake storage, or provided as events, however they provide it. But essentially this pipeline, which is essentially the mechanics of working with the data and transforming it, is the unit of architecture. And if you zoom out, this monolithic structure, if you look inside it, it's just a labyrinth of data pipelines connected to each other. But this is so fragile. One upstream failure causes cascading effects down all of the downstream pipelines, a very fragile coupled architecture. And at best, what I see is when people try to break down these pipelines into some sort of a meaningful components that they can then, scale out their operation in terms of people that are working on those pipelines. You have the ingestion services. So it's a bunch of people are working on how we're going to ingest data from upstream, transformation services, serving services, and so on. That at best, that's how I see people break down the pipeline. But pipeline is a fundamental unit of the current architecture we live in.
And related to that, Zhamak, is something you've touched on, I think, with Conway's law mentioned already. The final architectural failure you talked about in the article was siloed and hyper-specialized decomposition. And I guess that leads to a bunch of problems, yeah?
Yes, that's a sad, really, it makes me sad. This part of this failure mode really makes me sad because it affects the life of people who are working as data engineers or ML engineers in this system. If you think about this S-curve of growth or the maturity of a technology, and if you think about where we are on that curve with data engineering, I claim that we're pretty much early days of technology, as in we focus on skill set of people or focus on organization of the people around their skill set. So you find few data engineers that are so hard to find. Their skill set is familiarity and experience working with tooling of building these data pipelines. And then you put them together and say, okay, you're responsible for now, providing, consuming data, making sense out of it, transforming it and serving it for all these, consumption cases. And you siloed them in a corner of the organization. Even if you look at the hierarchy of a lot of enterprises today, you see the chief digital officer and then the data department separate from all of the other domains that form the operational world. So data is like separate from, if you're in commerce world, from your orders team or buy team or commerce team, and then you have data team, down the hall separate. So siloing people based on their skills leads to a lot of friction because these people, one, they don't know the domains where these data sets coming from. They honestly don't know. Like they don't know the order domain, the commerce domain. They have to somehow make sense of it. Any change in the signals of upstream would throw their pipelines into a red state, and they have to figure out what actually changed because they're not close to those domains. And they don't understand the consumption models. They don't understand the models that a data scientist wants to work on or the reports that a data analyst need to generate, and they have to serve their needs. So they're fairly siloed because of their specialization. And that leads to two problems. One is high friction to actually have a meaningful end-to-end capability delivery that crosses all these pipeline stages. And second, the skill set gap that remains, the number of people that actually get an opportunity to learn this tooling and the people that know this tooling but also know the domain, that cross-section is very, very thin.
That's been a great overview of the problem space. I think it's always really important to understand the problem before we look at solutions. But you have done a really nice proposal in the blog talking about the sort of next generation, a bit of a paradigm shift, if you like, of enterprise data platform architectures, which we're calling the data mesh. Could you introduce this to the listeners, please?
Sure. So it's going to be very hard to introduce it in one breath. I'm going to try to describe it in a multiple, sentences. As you mentioned, it's a new paradigm. And I know paradigm shifts is such an overused and abused phrase, but I think it fits here because what it needs thinking about data platform very differently. It needs a different language and different perspective. I will introduce maybe the pillars of it, the principles that are founding the concept of data mesh. The principles and approach is in response to the problems that we just talked about, right? The centralization, the silo, the lack of domain. So the very first principle is around how can we bring distributed architecture and distributed modeling to the world of big data? How can we break out this big monolithic problem to smaller problems? So it introduces kind of domain thinking and applying domain-driven design and domain-driven distributed architecture to the world of data. For example, if you really, really go stand on the moon, look back on Earth, look at a data mesh architecture, you shouldn't see pipelines anymore. What you should see is these nodes that are representative of a particular domain data set with a polyglot representation. So let's follow an example. Commerce is a well understood domain. So if you're in a commerce domain, you probably have your online e-commerce system that is generating data around your customer interactions. So your customer interactions is a domain-oriented data, right? You have your order management that generates analytical data around orders, what orders are being, all of the order events, right? What orders have been put through, canceled, fulfilled, delivered, and so on. Your payments, your customer, the analytical data. And again, I emphasize the word analytical data because there's a difference between, in my mind, operational data storage and operational data serving to analytical. Let's describe that in a minute. But analytical data, the nodes of this mesh, the nodes of this architecture, the top level components of this architecture are essentially polyglot domain-oriented data sets. And by polyglot, I mean a particular domain might provide its analytical data in multiple formats. As an example, it might provide the order events as an event stream, as an infinite log of events for consumption purposes that require near real-time access to the events, but also might provide order, daily snapshots as columnar information that is suitable for data science type machine learning training, batch model training, consumption cases. So the same domain might provide its analytical data, which is essentially all of the events and facts of the business that domain is generating in multiple formats for analytical and AI-based services. So that's kind of the domain-oriented decomposition of the architecture. That constitutes the first pillar. I hope I managed to explain the first pillar okay. And then the second principle underneath data mesh is that the idea of the platform thinking, because if you think about any distributed architecture, like even if we go back, if our listeners are familiar with, early days of microservices, when we said, let's decompose our architecture around domain capabilities, the very first problems we faced was, and the pendulum swung quite a bit, few times, was around, okay, there is a fair bit of technical stack and technology stack that we have to build to satisfy the needs of, in that case, microservices. In this case, these data domains. As an example, each data domain, we're talking about, large-scale data storage. We're talking about large-scale data storage for polyglot data. We're talking about the jobs that needs to still transform these data sets and serve them. So something like Spark clusters. So all of these pieces of technology, there's a fair bit of complexities there. How can we avoid duplicate, creation of these technology stacks across these decentralized data nodes or data teams, while we provide some sort of a consistency as well? So that leads to the idea of platform thinking, abstracting away all of the technology, bare metal, technical stack into a layer of self-serve data infrastructure. As an example, today, we have some teams that are building the data mesh, and one of the guidelines or the success metrics for the data infrastructure team is how quickly a new data product can be created. So let's say I'm in customer domain and I want to provide my customer change events or my customer information as a data set, right? How quickly can I build a pipeline? Quickly can I serve it? How quickly can I apply, role-based access control to this data set and providing that as sort of command? So platform thinking and abstracting away technical complexity into some sort of a self-serve infrastructure to give autonomy to these data teams, right? And I know I dropped the word data product quite a few times. That leads to my third pillar of data mesh, which is around product thinking, because one of the first concerns that I heard early days talking about data mesh was, well, we have decentralized data right now. These are the silos of application databases that we have. We have an e-commerce application with a database, and that's siloed. Nobody can get into it. And we have a customer database that is siloed, that nobody can get into it. So how can we avoid this siloing and lack of interoperability between these data sets that are now being distributed across this data mesh? And we can learn a lot from product thinking here, because the goal of having a data as an asset, if you think about that goal, how do we get there? How do we get to data as an asset? Well, we have to really treat it as such, right? We have to treat it as a product. We have to treat the users, data scientists, data analysts, as the consumers or the customers of that product. So for that to be really a product, it has to be discoverable. So there's a whole lot of capabilities we have to build around discoverability of these data sets. They have to be trustworthy. So they have to have some sort of a objective, measurable metrics of quality, timeliness that we need to provide, a good documentation and schema definitions and so on. So they're meaningful, and in a self-serve way, this data can be used. They have to be secured. So there's a bunch of requirements around these data sets or data products to really treat them as a product. And then you need to have people who act as data product owners that go around the organization and evangelize and talk about the data sets that exist and come and use the data. And they should be measured by how easily can somebody come and find this data and use it. And later on, how are we scaling usage of this data? Can we get more customers, internal customers for the usage of the data? So having that product thinking as the third pillar applied to data seriously, not just talk about it, seriously. And then the fourth pillar of data mesh is around interoperability and standardization. One of the big challenges of data lake or any big data platform is how can we harmonize the identities of entities that cross boundary or cross different systems, right? Customer in an order management system is a different ID from customer in the e-commerce system. How can we link these two together? And the standardization and interoperability across data products is a big part of this. So for you to run any distributed joins, you would need some sort of a harmonization. In the old systems, like master data management is a big topic. I don't want to actually use the phrases of the old paradigm because they're often overloaded and they imply a certain technology. But if you unpack that, there are concerns around standardized way of representing the data, standardized way of identifying entities or polysemes that go cross boundaries. There are a set of, the governance that needs to be applied to the mesh, and hopefully in an automated fashion for it to act as an ecosystem. So in summary, if I try to say it in one breath, data mesh is a paradigm shift that is applying domain-driven distributed architecture to big data and uses platform thinking to create self-serve data infrastructure and federated governance to create a harmonious ecosystem, and product thinking to deliver this data as a node on the mesh to the rest of the organization.
Thanks, Zhamak. I appreciate that. Is quite a complicated topic to break down, especially without a whiteboard. Yeah, and our listeners and myself, we don't have a whiteboard. So that was awesome. That was really good. I'll be sure to link to your article as well, because that gives some really good diagrams, I think. Just sort of wrapping up some of the ideas now, because it's been a really nice whirlwind tour. What do you think are the main challenges with the data mesh? People are listening. They like the ideas you've mentioned. What's going to be the pain points for them?
Given where we are today, the pain points fall into two camps. And the reason I say given where we are today, because our technology is not geared towards distributed architecture in big data domain. There are some technology that it's not that there isn't any, but there are technical problems, technical challenges that I see in this space, and we can deep dive into that for a little bit. And then the other side is the organizational challenge. On the organizational side, I think some of the challenges are related to data mesh, but some of the challenges are just related to how we are approaching data-driven programs of work. I think with regards to data mesh, the target state of a data mesh requires the operational domains take the responsibility of providing their domain data sets as kind of analytical data products. They're currently not incentivized to do that, right? If I'm an engineer or if I'm a product owner or a director of engineering running the e-commerce system, I'm incentivized on, how many transactions I make, how many conversions of my shopping cart to actually order I make, how well my site is responding. I'm not incentivized on providing my customer interaction information, events, or historical snapshots to the rest of the organization so that they can actually optimize my operation and build AI models to do personalization. Right now, I'm not incentivized. So be able to create incentive metrics and, KPIs and so on, so that the domains take the ownership of providing that not only capabilities, not only APIs for capabilities, but also providing their analytical data as a point of origin to the rest of the mesh I think is an area of, development. And I really don't expect any company that embarks on data mesh journey be there on day one. Really, bootstrapping data mesh looks very different from data mesh in a target state. So one of them would be just incentive structures around decentralization and decentralized ownership of the data, and the governance structure as well. Governance is also very centralized today, and the data governance teams have a very hard time to do what they need to do in a centralized way. So be able to federate that. That's on the really organizational side, and that I think applies to any monolithic to distributed ownership journey, right? We've seen that kind of with monolith and microservices. And the second set of challenges are around technology. There are a lot of, advances, mostly in the open source world, where you can kind of use the technology to apply it to a distributed data consumption model. And interestingly enough, those technologies have been, incentivized by dealing with the fragmented world of operational data. In a way, they have come to exist to deal with silos of data stores, but they can be also used in the world of data mesh. So let's say one of the concerns around a data mesh or any data platform is discoverability, like ability to discover data, to make sense of it, to see the documentation of it, and so on. And we've seen, a lot of open source systems come to play around the discoverability. But the reason they exist, not because teams like data product teams wanted to intentionally share the data and its documentation and all of its, lineage information. It's because the data was hidden and locked up in so many different databases, and they had to kind of make sense of it. So, for example, Lyft, Amundsen data discovery tool as an example of that. How did those systems come to exist to deal with the chaos of the fragmentation of the data? So they need to be a new generation of data discoverability tools to allow intentionally share data, the same way that, API gateways or API management systems allowed intentionally sharing APIs in a distributed fashion. So I think there's a camp around kind of organization, and there's a camp around technology. The other aspects of technology that I see are, white spaces for innovation, access control. So having distributed access control is a solved problem in the microservices world. Like Service Mesh does it using sidecars. There are protocols in place like SPIFFE for identification of services. There's a whole bunch of standardization of technology so that at every endpoint, at every access point, you can apply access control. That doesn't exist in the data world because depending on your underlying data storage, you have a different way of defining who can access to what. So there's no good standardization and a unified way of just applying a federated access control to all of these data nodes, which underneath they have different polyglot data storage, essentially, right? You might be an object store, it might be a relational database, it might be a graph database. How can we apply in a unified way data access to all of these nodes? And that's a challenge in itself as well. These are just some examples.
Thanks, Rad. We've covered a lot of things there, which has been really interesting. If people want to follow your work a bit more or dive into the topic of data mesh, what's the best way for them to do that?
At the moment, I think just following me on Twitter or reaching out to me on LinkedIn. I am setting up a data mesh website, so hopefully that will be up soon. And I will try to collect all of my talks and writings and so on in one place for people to be able to access. And I'm excited to see actually more writing is coming up on internet. I've read a couple of other blogs that other folks have started writing about. So I'm hoping that I will create a home for collecting that information at early days. I'm not trying to claim ownership of the space, but just a place to get started while we are in the early days of this movement.
Superb. Well, thanks for your time today, Zhamak. Really enjoyed chatting to you.
Thank you so much for having me. Take care.